Okay. So the next case that we're doing is the square root curve. So how do you sketch y equals square root of f of x? So again, very simple theory. The square root of something that's negative is undefined. So that's why you erase everything that's under the x-axis. The square root of 1 is 1. So you draw the line y equals 1 as a reference. Square root of 0 is 0. Vertical tangents become the x. Vertical tangents at the x-intercepts of the original curve. The square root of something that is bigger than 1 is less than the original number, and the square root of something that is between 0 and 1 is greater than the original number, and the square root of the asymptote of the old asymptote is the new asymptote. So I'll give you 2 examples. First one. Again, the same one, right? Same graph. So this is y equals f of x. So I'm going to do that in dotted. Then everything underneath the x-axis, I erase. They don't exist. That means you draw the line y equals 1 is the next step. So that's y equals 1 over here. That's 1, by the way, original one. It says here that the square root of 0 is 0. So that means the square root of 0. You look at the y value, by the way. You check the absolute, and when you check the square root of this, vertical tangent x-intercepts. What's that mean? So this is called an x-intercept. So that means that at this point, the curve starts off like a vertical tangent. In other words, when you draw a tangent at a point, it becomes vertical line. So what you do is you contrive it. You make a little spike going up like that. Yeah. And let me explain something here as well. So the square root of anything that is bigger than the square root of anything is bigger than 1 is under it, in other words. So over here, it's bigger than 1, so the square root is under it. And the square root of 1 is 1, by the way, from our theory that we have here, yeah? And then the square root of something that's less than 1. So here, the values of y is less than 1. So the square root of something that is less than 1 is actually more than the original value. That's original value. So more than means above it. So the curve then starts away with a vertical spike, and then it goes away, make it smooth, and it's above that one. But then this is more than 1, so it's going to be under it. So it's going to be under it. And then again, over here, it's going to be above that curve because of this theory here. Square root of anything that is between 0 and 1, it's going to be above the curve. More than, yeah? So it's going to come here, and it's going to go above it. And that's basically your curve. It's that simple. So when you draw a tangent here, it's going to be vertical spike. Vertical tangent, that's what it means. Vertical tangents means that the line that is touching the curve at that point, but then it's going to be vertical line. So this solid line here is y equals the square root of f of x. All right. Now, I haven't demonstrated this last bit, so I'll do that now. So I'll make up for you. So imagine now I'm going to shift this, and I'm going to do this. So now my new asymptote is y equals 4. And so that's my old asymptote, by the way. My new asymptote is going to be square root of that, which is basically 2. So whatever the curve is, that's going to result in, it's going to end up approaching that line. All right, so let me get rid of that arrow. So this become, yeah. All right, so that original curve there approaches this curve, which is y equals 4. This is now going to be y equals 2, so this is 4. And that's 2 down here. You have to draw the line y equals 1 as a reference, remember? Why? Because the square root of 1 is 1. Okay? Unfortunately, I drew very small here. Negative bits, right, don't exist. But the 0 do exist. So let's make it -3 here. So it's going to be 0 here. then it's going to be above the 1, and then after that, it's going to be below it. So after this point, it's going to be below this curve. So if I make this, I just make this up. So this is 4 and this is 9. So the square root of 9 is 3. So that's 2 here. So 3 must be in between somewhere. So that's going to be 3. So you need to know those points too. So there's 1 point. So it's got to go up there, under there, pass through the 3. So 2's down here and 3's here. It's very small. I apologize. And then it's going to approach y equals 2, which is this line here. So it goes there, and then it goes approaches that line there. So that's your square root curve. But I demonstrate the fact that it's there. So maybe if I drew that a little bit clearer, I don't know how, but I'm going to try. I'm going to exaggerate things. So that's y equals 1, 2, 3, and then 4. So 1, 2, 3, 4, and then that's going to hit it at 9 apparently. So 1, 2, 3, 4, and that's 9. So that's the original curve. The 4 is here, so it approaches that one there. Yeah. So it's going to hit there. It's going to be 0 there. It's going to be vertical tangent there. So you can strike away, and then it's going to approach this line here. So it's going to touch here as well. So it's going to go there, 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 and finally come back and approach that one there, which is y equals 2. But it demonstrates all these key bits up here, which is the square root of 1 is 1. The square root of 0 is 0. X-intercepts, in this case, becomes vertical tangent. So when you draw a tangent there, it's going to be a vertical line. It's going to go through the original asymptote is y equals 4. So square root of that would be 2. So your new asymptote would be y equals 2. That's a new thing down here for this curve. And that's basically that. So in the exam, it won't be this hard, right? It'll be this hard. Yeah. And that's basically square root. I'm going to stop there.